everyone, welcome back. In this particular video, we will be discussing the problem robot instructions. What is given is there is a robot starting at the position 0, 0 in a 2D plane. Obviously, you can assume that is starting from the origin node, from the 0, 0 node. Given a sequence of its moves, judge if this robot ends up at 0, 0 again after it completes all of the moves. So moves might be going up, going left, going right, going down. Something like those moves will be given to us. After all those moves, what we have to check is whether the final destination where the robot is it the same as source? That is it the same as 0, 0 origin node? So input format, as you can see, will be a string which will represent the sequence of moves, or you can say the move sequences, where moves of I represents the ith move. So there will be certain characters in that string. And if the string is of n characters, there will be n moves possible, where each valid move will be either right, that is represented by capital R, or left, represented by capital L, or up, represented by capital U, and down, represented by capital D. And we can for now assume that going up, left, down, right is only for one cell. That is one cell up, one cell right, one cell left, one cell down. So output should be either true or false, whether we finish at the same origin after all the moves or not. And of course, it is self understood that the moves should be in the same order as given in the input. Let's say if the input is containing characters UD, it means first go U, that is first go up, then go down, and check whether it is having the same answer or not. So what we are given is two sample test cases. Let's say UD is the first sample test case. So for that, let me just make a grid and then we will do a dry run. Given this grid, let's say we are starting from the origin. Let's say this is the origin cell, 0, 0 cell. From this cell, if we want to go up, what will be the previous cell which we will go to? The previous cell will be of the previous row. Why? Because if this is R0, this will be R minus 1, row minus 1. However, if we create matrix data structures, there are no negative rows, but right now there is no data structure as such. It is just simply the cells in a 2D plane. So what we will do is we will go to the minus 1th row with the same column. This is going upwards. And then after going upwards, what is the next possible move? It is down, that is UD. So first we went upwards, and now if I go down, it will actually go back to the same cell, that is origin, because going down means going to the next row. That is from -1, you will go to the next row, which is R0. So since the destination is same as origin, output should be true in the first example. However, second example is if you go 2 times left. So given that you have to go 2 times left, let's say this is the origin again, and we are going 2 times left. It means first left will be going to this cell, which is the previous column. These are columns, the vertical lines. The previous column, that is 0, -1, previous column. And again going left means again the previous column, that is 0, -2. So obviously after both the moves, you are not reaching the destination, that is at 0, 0. So it is not the target, or you can say output should be false. So sample test cases are pretty much easy. But before actually taking a bigger test case, let's see how we can make the moves. Given that, let's say we are standing on a cell which is R, C, how we can move to the top cell? Let me just represent top cell here. Let me just represent right cell here. Let me just represent down cell here. Let me just represent left cell here. So this is your up move, you can say capital U, right move, capital R, down move, capital D, left move, capital L. So as you can clearly see, going up, we already discussed, we are going to the previous row. What it means is row index will become -1 to the previous row, that is row -1, and column will remain same. Columns are verticals, so vertical will remain same. However, row will become previous row. What about down? It is just exactly opposite of going up. If you are going up by decrementing the row, going down will increment row, because you are actually going to the next row. Rows are nothing but horizontal. Row 1, row 0, or actually row -1, row 0, row 1, row 2, and so on. So same goes with left and right. When going up or down, you increment or decrement the row index or the x coordinate. While going left or right, you will increment or decrement the y coordinate. That is, if you will go to the right cell, you are incrementing the column. You are going to the next column. So row will remain same, row will remain same, horizontal level will remain same, column will increment by 1. Versus if you will go left, the row will again remain same, column will decrement by 1. So this is how the 4 moves will be made. So given that we know how to go to any of the neighbors, let's now solve a problem where first let's say we are going up, then we are going, let's say, left, let's say we are again going left, then right, then down, then let's say again right, and maybe you can say now we are doing right left or maybe down left. This is the scenario. So starting from, let's say, this particular cell, 0 comma 0 cell, let's say I am writing 0 comma 0. First you are doing what? First you are going up. Up means go to the cell previous it, that is the previous row. Then go to the left cell. For this cell, going to the left means going to this cell. I'm not writing the coordinates because coordinates you can easily write using this. Then again going left means again going to the previous column. But now going right means going to the next column again, that is going again to the same cell. Going down means going to the next row. Going right means going to the origin. So right now, even though we have reached origin again, but it is not the end of moves. We only have to check whether we have reached origin after all the moves are done. That is after all the choices are being made. After we are done with the traversal over the string. That is over all the characters are being uh, explored. So going down means going to the previous, or actually not previous, but going to the next row. And now going left means that going to the previous column. So as you can see, the target node is not the node which we want to reach. So it is answer should be false. Let's say if this was not left, let's say if it was up, then in that case, what you will go is from this particular cell, you will go up because it is not left, and then you will reach the origin. So it depends on how the moves are given, or actually you can do some optimizations. There is a better solution which can exist, which will actually count how many times you are going up, how many times you are going down, similarly how many times you are going left or right. But the brute force approach is just do all the approaches, or you can say do all the moves and check whether the target is equal to the source, that is origin. Because even if you are counting number of ups, counting number of downs, counting number of left and right, you are still required to run a loop. So it is not going to be optimization in terms of the time. It is just going to be a slight optimization in terms of the length of the code. Because what you have to do is you just have to count how many times up you are going. Let's say you are going up 1 times. So you will have to go down 1 time so that you are at the same horizontal level, that is at the same row. And if you are going left 2 times, you have to go right 2 times. If let's say this was also up, then you can say going that many times up, which is equivalent to down. So if number of ups is equals to number of downs, that is number of U characters are equal to number of D characters, adds as well as number of L characters are equal to number of R characters in the input string, then no need to do all of these moves. But given that this knowledge is very, very important because you will have to apply it in a lot of problems, let's do it with this approach by moving actually. That is by updating X and Y coordinate, by updating R and row and the column coordinate. So in order to move either up, left, down, right, it is a constant move because you are just incrementing or decrementing 1. That's it. So each move being constant amount of time, you are doing n such moves where n is the array's length, or not the array but the string's length. Overall time will be order of n, where n is the length of the string. And what about space? We are actually not requiring any extra space. Why? Because we are just requiring 2 variables, the row variable, the column variable. So constant space solution. Linear time, constant space solution. And finally, after all the moves, you just have to again apply a if else condition based on whether row is equals to 0 as well as and operator column is equals to 0 or not. So that is again a constant operation only. So let's now write the instruction manual. What we are going to do is we are going to start, that is initialize the row as 0 and the column as 0. Start from the origin cell. It is given in the question. Run a for each loop over all characters of the moves string. That is, go to each and every character. No need to get to the index. Go to each and every character means take U, D, L, R, whatever is present in the string, and check if it is U, check if it is L, D, R. So for checking, you can actually use a switch case. So apply a switch case, or you can also apply a if else if ladder. It is up to you. So maybe let's do it if else if ladder. If the character is nothing but U, we have to do up move. Else if it is not U, then it might be down. Otherwise, if it is not down, then it might be what? It might be what? Might be left. And similarly, if it is not left, it might be right. So given that the input will contain valid characters, it will only contain characters capital U, capital D, capital F, and capital R. You don't need to actually write the last if condition, that is if character is right. Automatically, if it is not up, down, left, it will be right only. So just a if else if ladder is what you are creating. If the character is up, how to go up? By decrementing the row, by going to the previous row. So decrement row index, row value by 1. Going down means exactly opposite. That is increment row by 1. However, when you are going left or right, it is about columns. If going left, you are decrementing the column by 1. And if you are going basically the right side, you are incrementing the column by 1. That is going to the next column. We have already discussed this. And when you are going up or down, there will be no change in the column variable. That is the horizontal level will remain same. When you are going left or right, the row will not change. That is you are going to remain at the same row or the same horizontal level. After we are done with the for loop, we have explored all the choices. Then what you can do is you can just check whether the final target node, that is the current cell where you are standing at, is it the origin or not. And when is at the origin? If row is a 0 as well as and operator column is a 0, so it is a 0, 0 cell. In such a scenario, you have to print true or return true. Otherwise, the answer will be returned false. It is not the origin. So very simple code, not that much, but you can just try to use different syntaxes, if else if syntax, switch case syntax. Even you can use other syntaxes also, which are present in different languages. So having said that, we are done with the first part of the video. As you can already see, we have already written the instruction manual or the pseudo code, and now we will be coding it in Java programming language. So please first watch the first video where we discuss about how we can go and explore all the 4 choices and how we can finally check whether we are equal to the target, that is the destination node or not. So we have to initialize our traversal from the 0th row, 0th column, that is row initialized with 0, column initialized with 0, both will be integers. Run a for each loop over all characters. In Java, there is no direct for each loop possible on a string. In order to run a for each loop over a string, you have to actually take out the character array from string. So how you can do it? You will take all the moves one by one. That is, let's say the variable name is move. And since the moves are characters, take characters one by one, one by one. Instead of running a loop over indices 0 to n minus 1, I'm directly running the loop over characters. Let's say if the string was this, I'm not running a loop on 0, 1, 2 until n minus 1. Instead of what I'm doing is directly getting the values of the string, or you can say characters in the string. But in order to do that, we have to convert after colon. Don't pass the moves, don't pass the string, but instead of pass it in a character array. That is use a function toChar array, which will take out the character array, or you can say convert the string into a character array, and then we are running the loop over that character array. If you don't know how to do a for each loop, maybe you can just go with the simple index based loop. That is also okay. Is that then you have to use a char at function to get the character at each index. Now that is removed. You don't need to do a char at because we are already getting the characters only. So characters can be 4 possible scenarios because in the question it is given that you will be having only such 4 scenarios possible. If character is capital U, and just ensure that you are using capital U. Otherwise, the entire logic will go wrong if you are using small letters. Similarly, if the character is, let's say, not capital U, but if it is capital D, if it is capital L, that is left, or if it is none of them, or you can say else, that is, it is capital R. If it is capital U, that is, we have to go up. And how do we have to go up? Is by decrementing the row. That is row minus minus. This is a decrement operator, unique decrement operator. Similarly, going down means incrementing the row by 1. So you will say R plus plus or the row plus plus. Similar thing which we have to do for the left or right. For left, decrement in the column by doing what? By column minus minus. Otherwise, increment the column by doing column plus plus. And after the entire loop is done, we know where the target cell is. So we will check whether the target where we have reached, is it the origin? Because we want to check whether we reach back to origin or not. So is row equals to 0? Not only single equals to, but double equals to for comparison. And ampersand operator, that is logical and operator, as well as column should be 0. If both are 0, then only we are in the origin. It is not like if you are having row as 0, column as 5, or maybe row as -3 and column as 0, it is not the origin. You are only at the origin when both row and column reaches 0 at the same time after the loop. And with that, we are saying that if it is, return true. Yes, that is what was expected. Otherwise, if it is not, then you can say return false. So a simple enough code. We have already done the dry run. Let's do what? Let's run it and confirm it is working or not on the sample test case. First by running the code and then submit it and check if it is going to work for any corner scenarios if exists. So till the time it is taking to submit, what we can discuss is the time and space complexity. Since the string is of n characters, we are running a loop over each character. The loop will take linear time or order of n time. Inside the loop, we are just using if-else operators, or you can say constant operations. So overall time of the entire code, including the last check of the origin, it is linear order of n. And what about space? We are not actually taking any extra space. We are just creating two variables, row and column, 4 bytes each. So the space complexity for this problem is constant. Given that we usually don't include the input space in the extra space complexity. We are only talking about extra space right now, which is order of 1 constant. So with that, we are actually done with the problem robot instructions. And we will meet in a new video with a new problem. Till then, bye bye. Take care. Keep coding.